Look at a modern electric vehicle. We spend years obsessing over the aerodynamics, the light signatures, and the exact curvature of the glass. The feature determining this car's survival lives hidden underneath. An EV carries its most expensive component, a massive battery pack, right in the floor pan. When lifted for maintenance, the margin for error shrinks to zero. Manufacturer lifting points are reinforced, but often sit just centimeters from the fragile battery edge. Miss that reinforced point by an inch, and the pressure crushes the battery housing. That breaks the protective seal, lets in water, and ruins the internal cooling passages. A slight miscalculation by a technician turns into a 5-figure replacement cost. Yet these high-stakes decisions are made in rooms like this, bright, isolated design studios, where concept waddles live in a perfect digital space. The jacking point is usually drawn late in the process, completely removed from physical context. The engineers sitting at those desks can specify exactly where a lifting point should go, but they have absolutely zero control over the machines that will actually do the lifting. Treating a jacking point as a minor detail in a vacuum ignores the physical reality it has to inhabit, locking a permanent vulnerability into the vehicle's architecture. That physical reality looks like this. It is the least glamorous room in the automotive industry, and it operates by its own set of rigid rules. This is the installed estate. Hundreds of thousands of two-post lifts and steel arms bolted to concrete floors years before your electric vehicle existed. Much of it will still be there long after your car is scrapped. The disconnect happens in the timeline. The pack footprint and the sill architecture of a new car are locked in long before anyone stops to consider the swing radius of a 15-year-old lift arm. A standard two-post lift needs a low-profile arm. But legacy geometry often collides with a modern EV's dropped battery pack before reaching the pad. Once lifted, the EV's low central mass changes the physics completely, drastically altering the center of gravity on aging supports. When you design a modern product for an idealized world, it will inevitably collide with the inflexible machinery of the real one, and the machinery always wins. The immediate answer on the workshop floor is an adapter, a heavy steel block or low-profile arm extension bought specifically to bridge the gap between the old lift and the new car. The industry adapts, but look at who pays for it. The correction is bought downstream by thousands of independent shops, one adapter at a time, to solve a physical problem they did not create. That problem was authored miles away, signed off years earlier by a team that will never visit this specific workshop or stand by this specific machine. Because the technician solves the problem on the spot with a credit card and an adapter, the failure is never fed back to the design studio. The people living with the mistake have no route back to the people who made it, so the exact same geometric blind spot remains available to be drawn into the next vehicle. Forcing the end user to buy a downstream workaround doesn't actually solve the design flaw. It just turns an upstream oversight into a permanent, recurring tax. The most rigid constraint your product has to fit isn't a government regulation, it isn't a cost target, it is the existing estate of tools waiting to receive it. You have to remember the core assumption built into that estate. Every machine, rack, and bay was designed assuming your product will break. The only way to avoid this trap is by making the concept phase highly legible long before physical manufacturing begins. Legibility means you can interrogate a design against the physical constraints of the real world while the model is still entirely digital. Fixing a clearance issue in software takes minutes. Finding out your geometry is wrong after the chassis is tooled, stamped, and shipped is an expensive, permanent mistake. Nobody applauds a correctly placed jacking point, but everybody pays for a bad one, except the people who chose it. Design decisions demand total visibility before the build begins. At Depix, we believe you have to see the constraints while they are cheap, because once they are physical, they are permanent.